Just like the scheme I gave you some time ago, in essence, to first as logarithm, second one say logarithm, first and second week. The third week approximation, and the fourth week is now sequence. So I'm going to introduce you to sequence. Sequence. Sequence has three branches, namely arithmetic progression, geometric progression, and series. The branches are one, arithmetic progression, popularly referred to as AP, North African Petroleum, AP. Also have geometric progression. We refer to as a GP. And finally, last but not the least, is series. Arithmetic progression, AP, geometric progression, GP, and series. I'm going to start with the arithmetic progression in that order. After arithmetic, go to geometric. After geometric, go to series. Arithmetic progression. AP for short. Arithmetic progression. How do you know that numbers are in arithmetic progression? How do you know arrangement in such a progression? Let's take our 1, 2, 3. 1, 2, 3, 4, 5, and so on and so forth. Something is happening. Our 1, 2, 3, 1, 2, 3, 4, 5, 6, and so on. Something is happening. If you observe very well, and that thing is constant, repeatedly, keeps on happening. And what is that? We're adding 1. Before getting the next one, I say plus 1. So 1 plus 1 gives us 2. 2 plus 1 gives us 3. 3 plus 1, 4, and so on and so forth. So there's addition of constant number, 1, 1, 1. Such an arrangement of numbers is said to be in arithmetic progression. When something, either you are adding or subtracting. EG2, if I am, say, 100, minus 5, I'm minusing 5, 95. Minus 5, 90. And 5, 85, and so on. So when you have an arrangement of numbers that will obey certain condition, and that condition must be either you are adding or subtracting. So let's tell my student, if I just say arithmetic progression, I must put a plus or minus as a guide. Then if it's arithmetic progression, remember, have it at the back of your mind that you are either adding or you are subtracting something. That's AP for you. You are adding or subtracting. So if I have an arrangement of number like 1, 2, 3, or 1, 2, 3 system, it's addition of 1. 1 plus 1, 2 plus 1 plus 1. Or you can say 100 minus 5, minus 5, go. So when I say quantities are set to, if you want definition, can I define arithmetic progression? By what definition? It's not compulsory. So quantities on arrangement numbers. Quantities or numbers are said to be in arithmetic progression. Are said to be in arithmetic progression in arithmetic progression if they increased or decreased with a common difference. Increase, either they increase or they are decreasing. Either they increase or increase with a common difference. With a common difference. Quantities or numbers are said to be in AP if they increase or decrease with a common difference. E.g., 1, 2, 3, 1, 2, 3. It's addition of 1 plus 1 plus 1 goes on. So it's addition of 1. Now take again 2. If I say 100 minus 5, 95. Minus 5, 90. Minus 5, 85. So here I'm adding 1 plus 1. Here I'm minusing 5. That's saying in AP, either you are adding or you are subtracting. Addition of and the same number constantly, or you are subtracting the same number. That's the arrangement. Now, the first number is denoted by A, first term. First term is denoted by A. By A. First term is denoted by A. That thing that is happening, common difference. The common difference is denoted by D. Common difference denoted by D. The nth number you want, nth term you want, nth term is denoted by n. By n. Then the last of them, the one you want, the last term n. L equals the last term you want. Now there's a formula for this AP. There's a general formula. The general formula says we may not bother to derive it. There's a formula, there's a way to derive it, derive the formula. Not for this scope. Not for our scope, maybe there's higher level. You derive the formula, there's a formula for you to derive it. But it says that L1 equals A plus N minus 1. Common difference. Note this better. That's what we're going to the back of the math. That's what we're going to use. Now for AP, the formula is the last time we're looking for equals A plus N minus 1. Where A, let me explain it further here now. I'll say it before, let me define it here. L equals A plus N minus 1D. Where A equals first term. First term. This is the common difference, as earlier said. Common difference. And n term want. N term you want. And they are the last number. That's the formula. L equals A plus M minus 1D. So minus M minus 1D. Where A is the first term, D is common difference, N is n term, and L is the last term. Let's take our 1, 2, 3 for example. Example number 1. 1, 2, 3, 1, 2, 3. So. Want to be number 10. Want to be 10th number. If I consider 1, 2, 3. I told you 1, 2, 3 is arithmetic. It's progressing. Arithmetic with 1 plus 1 plus 1 plus 1 plus 1. If I continue, what will be the 10th number? We know about let's do it now. And the formula says L equals A n minus 1 times D. Where A is the last number I want? Do I know A here say I am 1 first term. Then what is happening to them? I say I'm plus 1 to get the next. So D. The nth number says we are looking for number 10. Look for number 10, the 10th number, we look for the 10th number. So N means I'm looking for number 10. Therefore, record the formula L equals A n minus 1 times D. Last number I don't know, but I know A. My A say I am 1. N say I am 10 minus 1. Common difference say I am 1. So L equals 1 plus, this one is 9. N times 1. 1 plus 9. Therefore L equals 10. That's why I want to 3 if you can 1 to 3, but number 10 will be 10. I'm going to give 2 other examples again. I was going to keep on adding 5, 5, 5, 5, 5. What will be number 20? Example number 2. Find the 20th number in the AP, 5, 10, and so on and so forth. 2 numbers enough to tell what is happening in an AP. 2 numbers. I don't need to write on 3 or 4 numbers. No, just any 2 numbers. I'm writing 5 and 10. First, what is first term? What's common difference? My first term, the first number you're writing. First term, which is my A, equals 5. Common difference, D. Now, another one knowing common difference, take any 2 consecutive happening, pari passu next to it. If I say 1, let's say I'm adding 3 now. 1 plus this 4, plus 3 is 7, plus 4 10, plus 4 13. Now, if I want to get the common difference, they say take any 2 close numbers, consecutive numbers. Subtract the 1, these 2. I'm taking, for example, I'm taking 4 and 7. 4 and 7, 2 close numbers in the series 1, 4, 7, 10, and so on. Take any 2 close numbers. Subtract the one on the left from the right. As if from the right minus the left. Right minus the left. And that gives you the common difference. So take it out. Common difference here, divided by the right one minus the left one. In any 2 consecutive numbers. 2 consecutive numbers. Any 2 numbers in the arrangement, the series there. Take any 2 close numbers. Keep on that, keep on. Minus 100 left from it. That tells the common difference. So when we look at the total number here, 5, 10, there's just two close number 10 and 5. I want to, my common difference, I say the right. The right minus left here. My right is what? This two number. My right is 10. My left is 5. So common difference, therefore, D equals 5. That's how to get common difference. Common difference. The right minus the left in any two consecutive, just close numbers. Nothing in between them, close numbers. Like 4 and 7. 4 and 7. 7 is next to it. So consecutive. The right is 7 minus this. If I take the last two, 10 and 13, consecutive number, two consecutive. The right, my right is 13. My left is 10. 13 minus 10 is the same 3. Which you got to common difference. Sorry, look. Not this example, I'm taking another example. Actually, if I take the common difference is 3. The same thing if I take it 3 minus 3. 7 minus is 3. To get it for this example. But for now, we're taking 5, 10. So find the 20th number in this series, in AP. 5, 10, and so on. First time we know it now to be 5. Common difference is not this. The nth term means the number they want. They say we should look for the 20th. And I equals number 20. I'm looking for number 20. What's the last number? I say, I don't know. That's number 20. First term is 5. Common difference CD is 5. Then nth term, the number they say we should stop at number 20. What's that last time? I don't know. So let's apply this formula now. Now, in the question, you are given the first term to be 5. Common difference to be 5. And they say look for the 20th number. Now, I'm not looking for last number. But the formula says, always have to at the back of your mind. A plus n minus 1 times the common difference. We know A to be what? 5. N equals 5 plus n. N say I am 20. 20 minus 1. Common difference say I am 5. 5. N equals 5 plus this 19 times 5. This there's any invisible times here. Times 5. N equals 5 plus this times this. So I count for 95. Equals 100. So you continue to add 5 plus 5 plus 5. If you get to number 20, your answer is 100. That's what they're telling us. I give an example with where it's addition. What happens if it is surprise? Because that's example number 3. Find the 10th term in the AP, and now let me be surprised now. 100, 95, 90, and so on and so forth. Find the 10th term. In example number 3, we are given a number 100, 95, 90. They should find the 10th number. Start again. The formula says L equals A plus N minus 1 times D. And I ask you, what is A? That's your question. My A says I am 100. My D says, take any two close steps. 95 minus 100 minus 5. This says I am subtracting 5 from all the numbers. The L say N says stop at number 10. I'm looking for number 10. But the formula says L equals my A say I am 100. N say I am 10 minus 1. And this is minus 5. I always advise students, this minus 5 is not this minus. No, you are going to multiply because the difference is minus 5. So it's advisable to put them in a bracket. So here is 10 minus 1, and since it is a minus 1, the difference is minus, put in a bracket. Otherwise, you just this is this minus this 9 minus 5 4. No, put in a bracket to remind you that is multiplying that thing. Therefore, L equals 100 plus this minus this is 9 times minus 5. You cannot open the bracket. But if I left it like this, it may ironically say that this is this 9. 9 minus 5 4. No. So always close in the bracket. Now go. L equals 100. This side is now minus 45. Sorry, 10, please. Yes, we're looking for 100. We're looking for the 10th number. Minus 45. So this time is 45. And that's 55. Therefore, L equals 55. So if you keep one minus, say 5. Number 10 will give you 55. Let's be practical whether it works or not. As we don't tell her, but let's see what I've told you this time around. Keep on minus saying 55. 95, 90, 85, 80, 75, 70, 65, 60, 55. What do you say? 55. Stop here. How many numbers have we got now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we're telling that 10th number, not 10. That's where I want to end for today. I will just introduce progression. Arithmetic progression. As a habit at the back of your mind, what's the progression? It's either you are adding or subtracting numbers. Either you are adding or subtracting, same thing. If you're adding continuously without change, the same number. If you're subtracting continuously, the same number. Either you're adding or subtracting, that's arithmetic progression. I'm going to start from here next time. We're going to take more examples. And we're also going to form equations. There's a stage where we're going to form equation. Maybe if you are getting 2 times, if I told that and the progression is 2x, and so on, maybe 2, if I'm adding 5, 7 plus 5, 12. 12 plus this, 17. X and y, find x and y in this progression. The stage where we're going to find. If I keep on adding 5 plus this, 7. 7 plus 2, 12. 10 plus 5, 17. Goes on. So then we just give you 5 x and y. We're also going to give, maybe if I now know x, if here is 5 plus 5 is 7. And I know 17. I say I can just give you 7 and 17. The second and maybe 4th terms of an AP. How do we determine the AP? I may just give you the second and 4th term of an AP. Say find the rest. I can also give first arrangement. Say find x and y.